Okay, so I want you to show the total. So this question here is question 7, section B of 2012. So we had to answer both these questions. Show the annual total sales of cars over 6 years using suitable charts. Now we can see that like there's just each year, January to March, April to June, July to September, October to December, annual total. Engine type of car sold, petrol, diesel. Okay, so it wants us to go to the annual total sales. So that's just the grand total here. So what I reckon we might do here is it wants the annual total. So the annual total is basically this line here. It wants us to compare 2006 all the way up to 2011. So this is the annual totals. Annual total keyword. Okay, suitable chart. Just use a bar chart. Bar chart is going to be very easy to use. Okay, so we might go from a scale of 1 to 18 maybe. Might be a good choice here. So might just go about making this picture a bit smaller. Okay, then we can use it a bit better. Okay, using the suitable chart, so we can use it like this. So what we're going to do is we're going to do a line here like so to the bottom and over. Now what I'd like to do here is I'm going to go up in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. Now what we can say is that this is the annual total. So I can say this is the annual total. Annual total. Annual total sales, okay? And each one is worth 10,000 sales. One is worth 10,000 sales. Okay, so it's worth 10,000, okay? So what we can get next is 2006. So let each one just give it a gap of about 3 bars. So that's 2006 total. Then this one here we can put in a gap here. This one can be the 2007 total, worth another 3 bars. Give it another gap. 2008 total. 2009 total can go here. Give it another gap. 2010 total can go here. And then finally the 2011 total can go here. Now you're just looking to do a rough estimate, okay? So look, 173,273. So it's going to be up around the 17 somewhere, okay? So we'll just try this out here. So 2006 is around 17,000, somewhere in the 17,000 bracket. There's your first one done there. The next one, the 2007, is 180,000. So that's going to be over 118 mark, somewhere around there, on the 18 mark. Okay, the 2008 total was 146,000. So it's going to be around 14 and a half. So in between 14 and 15, 14 and a half thousand. Okay, the 2009 total was 54,000. So you can see that it's really dropped drastically in that one. So it's about 50,000. Go to the 5 and about up another half, 54,000. And then the 2010 total would be 84,900. So about 85,000, 8.5 in between 8 and 9. Built here. And then 2011 total would be 2011 total about 86, so just slightly taller than the one I just did. Okay, so here's your bar chart. Okay, and find the mean number of cars sold over the 6 years. So to find the mean, I need to find the average of all the cars sold. Okay, so need to add them all up together and divide by 6. So what I'm going to get is 173 273 plus 180,754 plus 146,470 plus 54,432 plus 84,907 plus 86,932. And what I gotta do is I gotta divide all of that by how many years there is. So there's basically 6 years worth here. So divide all that by 6. Just put it into the calculator, and I'm going to get 720. I'm going to get 726,768. Gonna have to divide all that by 6. So the mean, or average sales, is going to be, the mean will be 121,128. Okay, next part of this question. Calculate the percentage increase in annual car sales between 2009 and 2011. So between 2009 and 2011. So the increase, if we go back here, is we need to find 2009 to 2011. So 2009 being 54,432, 2011 being 86,932. So to get the increase, we just say 86,392 minus 54,432, and that will get me 32,500. Now, the increase is measured on what it was in 2009. So the percentage increase equals the increase, which is 32,500, divided by what it was in 2009. It was 54,432. Got to multiply this by 100 over 1 to change it into percentage. Now what we get is 59.71%. Put in the calculator. Eva says that this increase shows car sales are currently going well. Paul says that car sales are currently going badly. He says that the sales have fallen 52% since 2007, and they are well below average. Complete the sentences below to give a criticism of each argument. Okay, Eva's argument does not recognize that this increase, now the increase Eve is talking about, this increase comes from a, like if you look at 2009, it comes from a very low base. 2009 was the record low year, so it comes from the year with the lowest sales. So she's just comparing it to the year that has the lowest sales, so it's more likely going to increase anyway. Okay, and the sales had been, and she fell with low sales, and sales had been much better pre-2009, or had been much better pre-2009. So she only compared it to 2009, and if you look at before 2009, the sales were up in the hundred thousands. Okay, so Aoife is not seeing the full last 6 years. She's only tested from 2009 to 2011. Now, Paul's argument does not recognise that although sales are lower now, although sales are lower. And what was Paul telling me? He was talking about 2007. Than 2007. They have risen. Since 2009. So basically, if you go back to the numbers here, Paul is basically saying, look, compared to 2007, it's much lower, but he's failing to recognise that since 2009, it's actually on its way up by about 30,000. So there's two sides to the story, so he needs to recognise both sides, okay? Okay, so they have risen since 2009. Give a more balanced description of the pattern of car sales over the last 6 years. So over the last 6 years, we need to count the full story in, okay? So they've dropped since 2009. 2006 to 2009 has dropped drastically. But since 2009, sales have risen gradually, okay? So we'll see what we can write this in language. Sales fell dramatically from 2007 to 2009. 2009. They've recovered a lot since then. Recovered a lot since then. But are still much lower than they were. Are still much lower than when they were. Still much lower than they were at the start. At the start. Okay, so still much lower than they were at the start. So we need to get rid of that part there. Okay, so now we know what that is. Okay, now describe how the sales of the cars are distributed over the 4 quarters of each year. Okay, so the 4 quarters of each year. So we need to go back and we need to look at the 4 quarters of each year. Now we can see that January to March seems to have the most amount of sales. April to June, not as much as January to March. Then it sort of falls off. July to September, not as many people buying goods. Then October to December, like sales have dropped. So here's the 4 quarters: 1, 2, 3, and 4. Okay, so we got to describe what's happening there, basically, more or less. Okay, so describe how car sales are distributed over 4 quarters each year. Highest quarterly sales are in the first quarter. It doesn't want the reason why, it just wants the description. In the first quarter. In the first quarter. And decrease significantly. Significantly means a good portion. Significantly in each subsequent quarter. Now subsequent means when it follows one after the other. So basically each subsequent quarter, so the quarters that follow it, it decreases. So we can see 75 to 54, 54 to 32, 32 to 10. You can see that it just keeps dropping from quarter to quarter. Okay. Now, suggest a reason for this pattern of sales. People like to buy cars early in the year. Buy new cars early in the year. Early in the year. Early in the year, so that they have the new number plate for longer. Have a new year number plate. Basically, if you're going to buy a car December, let's say 2012, you might as well wait to January 2013, because the 2013 registered plate means it won't devalue as much. Okay. Now, the sales for the first quarter 2012 are 36,081. Find with justification estimate for the total sales for 2012. Okay, so what we need to do is we need to have a look at the first quarter sales and what they're like to the overall sales. Okay, so let's say 75,000. So 75 769 divided by 173, 273. Let's see what sort of fraction that comes out as. Now it's 43%, okay? Now that was back in 2006. Let's try 2010 and 2011, okay? So 2010 maybe 34,555 divided by 84,907. Okay, it's 40.6%. And then finally we can say 39, the most recent year. We can only assume that it'll go on the most recent year. So 2011, 932. Let's have another look at this. 39, 484 divided by 86, 932. And we got there is 45%. So we can roughly say it's going to be 40 to 45% of the entire sales, okay? So we can just justify this back here. So sales first quarter sales account for 40 to 45% of total sales. So this means that this number here, we can pick the middle. Let's call it 42.5%. So 42.5% of all sales equals 36081. To find 100% of the sales, we're going to divide by 42.5, multiply by 100. So divide by 42.5 to find out what 1% of the sales is, then multiply by 100. So what we get is 36081 divided by 42.5, multiply by 100. And you can say about 84,896. Right. Another way maybe of answering this question would be to say that they're very similar to the sales that just took place. So you're expecting them to be in the same region as 2010 and 2011. So that's another way of doing the same question, okay? So it's not too bad. Now, moving on. Two pie charts are being used to show the change from 2006 to 2011 in the popularity of petrol and diesel cars. Complete the second pie chart, right? So petrol and diesel, right? So if we go back to the chart here, okay, in 2006 there's this much and this much petrol, diesel and other. Okay, so we can see that petrol, diesel and other. So what we need to do is we need to take down the figures for 2011. So for 2011, the amount of cars sold, total cars sold, equals total cars sold equals 86,932. Okay, so petrol, we need to figure out what fraction was petrol, okay? So petrol was 23,000, so just keep going back and referring to the petrol was 23,000, diesel and other. Okay, so we need to find out what portion of the chart these should take up. Okay, so petrol was 23,246 divided by 86,932. Diesel, if I can spell diesel correctly, that is, diesel is 61,730 divided by 86,932. Okay, and other ends up to be 1956 divided by 86,932. Now what you got to remember about circles is that this is the fraction. To get the angle we need to multiply by 360 degrees. What fraction of the full circle does it require? Okay, so this is the fraction. We're going to multiply that by 360 and then we can figure out what each angle warrants. Okay, so what each section warrants on the graph. Okay, so we have 360 here. So what we're going to get is the first one is going to be 256 degrees. The next one's going to be 96 degrees. And the last one's going to be 8 degrees. Okay, so let's start off with my pie chart here. Okay, so what I can do is I can get myself a protractor. Okay, now my protractor here. Just going to make it a bit smaller. Okay, so let's rotate this around a little. Okay, so the first thing we need to do is we need to find about 90 degrees. Okay, so what can I do here? So this is 90 degrees from the starting off point up here. Okay, so I'm looking to find 96 degrees. Okay, so I'm just going to turn this around until I get 96 degrees like so. Well, actually I'm going to measure it just using the old-fashioned way. Here's 91, 92, 93, 94, 95, 96 is around here. So if I was to draw a line going from here to here, this here would be 96 degrees. Okay, so I'm in business. That's my 96 degrees. Okay, next part, I'm going to add on 8 degrees. So I'm going to go from 96 degrees here, if I have, to 104. So I'm going to try and find where 104 is. 96 to 104. 104 is about here. So then I'm going to get my other cut here, slither in here. Okay, and now I am very much done with this graph. So as you can see from my graph here, this is going to be 8 degrees. This is going to be other. It's worth 8 degrees. This one here is going to be now petrol. Sorry, I got my two angles mixed up there. Diesel is the big one. So diesel was 256 and petrol was 96. Excuse me, you can see that petrol is much smaller than diesel. So this one here is going to be petrol. And this part here is going to be diesel. Okay, now what also wants is percentages. Okay, so I have to put in percentages of what's going on. So to get percentages, instead of multiplying by 300, what I can do is I can multiply by 100 over 1. So don't multiply by 300, multiply by 100 over 1. So to change fractions into percentages, you just multiply by 100 over 1. So what we'll get this time for each section is we will get other is going to be 1956 divided by 86932 multiplied by 100. It's going to be 2.25% roughly. Okay, and then diesel is going to be roughly 71%, and petrol is going to be 26 points. Diesel is going to be 71%, and petrol here is going to be worth 26.7%. Okay, so now that we've put them in, we just need to put them into the top here. So call this one 2.3 because it doesn't work out otherwise. You got to make sure that all adds up to 100%. So petrol is going to be 26.7%, and diesel is going to be 71%. Now look at the change, guys. Petrol was 74%, now diesel 71%. Diesel was 24.5%, now it's 71%. So you can see a massive swing from petrol to diesel, okay? Which of the following statements best describes the change over time property? Diesel cars have suddenly become very popular over the last 2 years. Diesel cars have increased very steadily property over the last 6 years. Diesel cars have become very popular since this car sales started to improve. D. Diesel cars got more popular each year, especially with a big increase in 2009. So let's have a look here. 2009, the recession. So we can see petrol was very dominant petrol is very dominant all the way until 2009. But in 2009, there was a change from petrol to diesel, and then all of a sudden diesel came the dominant brand from 2009 onwards, when people became much more, shall we say, money conscious, okay? So what we can say here is D. Okay. Now, and the survey of the most popular models of private cars sold in 2011 examined CO2 emissions in grams per kilometre from diesel and petrol engines. The data is as shows. Construct back-to-back stem and leaf plots of the above data. Okay, so what we're going to do here, just going to put in our numbers. This stands for 100, this is 110, 112, 113, 130, 140, 150. Now please remember to put in a key. Keys get you the full marks. 12/9 means 129. And the other way around. Okay, so we have 1 on 107. Okay, and this can be diesel. And this can be petrol. Okay, then we have 110, 4, 6, 8. Oh, sorry, there's a 7 in there as well. 6, 7, 8, 9, 9. Okay, so these are all the 1100s. And then we can have 0, 5, 5, and then 4. And then we have 129, 129, 129, 9, 9, 9. 3, 4, 6, 8, 8, 9. Okay, and then we have 0, 7, 9. Now remember the key for the other side. Another key could be 4/13 equals 134. So remember a key for both sides. Thus the information suggests that diesel produce lower CO2 emissions than petrol cars, and in your answer you should refer to stem and leaf plot and to the appropriate measure of central tendency. Okay, so survey the most popular models of private cars sold in 2011, examined CO2 emissions in grams per kilogram from diesel engines and petrol engines. The data is as follows. We can obviously see that the diesel cars, the tendency is around the central point of the 1100, so we can see that the diesel cars produce on average less grams of CO2 when compared to the petrol cars, who have a peak in the 1300s. Okay, so what we can say is that yes, the diesel engines grouped at the top of the plot. So they grouped at the top of the plot. So what we're saying about the diesel cars is you can see that they're all in between the 10, 100 to 130. From 100 to 130, while petrol cars grouped at you can say roughly 120 to 150. Okay, so 120 to 150. Okay, you could also go about doing the median. We have 1, 2, 3, 4, 5, 6, 12 cars. So to get the median, it's 12 divided by 2, which is the 6th and 7th car. So we get the two medians here if you wish. 1, 3, 4, 5, 6, 7. So that's the diesel median. 1, 2, 3, 4, 5, 6, 7. Okay, so we can get the two medians here. 118, 119 divided by 2. and for the petrol it'll be 136 and 138. So we can compare the two medians. The median of the petrol median, or the middle petrol, is 118.5, while the diesel median is going to be 137. So we can see that the petrol median is much lower than the diesel median, and also the diesel medians have a much lower mean. So they have a much lower median and mean. So you could add them all up, add up all 12 and divide by 12, and you'll see that the diesel mean is lower than the petrol mean. Okay, so you can do any choice you want. Okay, just mention the median and the mean, and that'll pretty much guarantee your marks. This information suggests there's a greater variation in the CO2 emissions of diesel engines than petrol engines. In your answer, you should refer to 7-leaf plot and appropriate measure of variability. Okay, I think we need to go for the range. Okay, so the range is 107 to 134. So the range of the diesel range is 134 minus 107. So the range of the diesel is the highest minus the lowest value, and that's going to get me 27. And the petrol is going to be 129 to 159. Petrol is 159 minus 129, which is going to be 30. Okay. Now, okay, so what we can say is that the range of the diesels is smaller than the petrol. The range of the diesel car is smaller than the petrol. Okay, so does the information suggest the greater variation of CO2? No, it doesn't. So the answer is no, because the range of the diesel car is smaller than that of the petrol. Okay. Now, what you could also do is you could also get the interquartile range. Okay. So we could argue that point first, and if you wanted to, instead of using range, you could use the interquartile range. So the interquartile range would be 12 divided by 4, and 12 divided by 4 is the third and fourth car. Okay, that's for Q1. And for Q3, which is the upper quartile, it's 12 divided by 4 multiplied by 3, and it's the average of the 9th and 10th car. So that'd be 9, 9th, and that'd be equal 9, but because it's an even number, it's the 9th and 10th car. So what we could do here is we could say the third and fourth car, 1, 2, 3, and 1, 2, 3 and 4 would be 114 and 116 for Q1 for the petrol. 114 plus 116 divided by 2. Okay, so we can just rub this out for a minute and do the interquartile range of diesel and petrol, because that's diesel. Okay, Q3 is the 9th and 10th car for the diesel. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 120 and 125. For the diesel again, 120 plus 125 divided by 2. Now, in general, the interquartile range is more reliable than that of the normal range, because it takes out the extreme values. Okay, so let's go for the petrol car. So the third and fourth value of the petrol car, 1, 2, 3, 129 and 133. So 129 plus 133 divided by 2. That's for the petrol car. And then the third quartile for the petrol car is the 9th and 10th value on the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 139 and 150. And you can divide them by 2 as well. So what we're going to get here is we just need to put these in. So that's going to be 115. This one's going to be 122.5. This one here should be 131. And this one here should be 150 plus 139. 144.5. So interquartile range. Okay, so it's going to be Q3 minus Q1. And for the diesel, it's going to be 122.5 minus 115, which is going to be 7.5. And for the petrol, we can see that it's 144.5 minus 131, and what we're going to get is 13.5. So once again, you can see that the diesel has a lower interquartile range, so therefore it shows you that it's less spread out. Interquartile range. So shows that it's less spread out than the petrol. Shows less variation in results. Now always refer back to the question. Less variation. That's one of the words in the question. Greater variation. I'm saying it shows less variation in results than the petrol. Okay. Okay. Now explain what's meant by a scalene triangle. A scalene triangle is a triangle with 3 different lengths of side. Okay, so if you were to look at a scalene triangle, just draw one here maybe. So a scalene triangle, you can see that none of the angles are the same and none of the sides are the same. Okay, so definition: a triangle in which all 3 sides have different lengths. Okay, next one. Triangle EFG is the image. Now image means it's an enlargement of CDE under enlargement, and the triangle CDE is the image of the triangle ABC under the same enlargement. So EFG, we can locate my target. EFG is the big one here. Is the image of CDE, so you can see that they're the same shape, basically like so. These ones here, okay. And CDE is larger ABC, so we can see that. Look, these triangles here, they're just getting bigger and bigger and bigger. So you can see ABC here. Just that's the first one. The second one is a larger version of that again, and then the third one is a larger version again. Now it says under the same enlargement, so it's getting bigger by the same amount each time. So there's a scale factor involved here, okay? So you can see 7.2 turns into 9, and then 9 is going to turn into whatever we call this x, okay? So we need to compare the same side. So this side corresponds to this side, and this side corresponds to this side, okay? So AB corresponds to CD, CD corresponds to EF, regards to the size of the triangle. The proposed dimension of the structure AB is 7.2 meters, BC is 8 meters, CD is 9 meters, and DCB, let's see where DCB is 60 degrees. Now what this 60 degrees means is that basically it's maintained. The 60 degrees is maintained because they're enlargements of each other, okay? So that's okay. Now, find the length of FG. So F to G. So we have to find out here, this one to this one, okay? F to G. Now, suppose what we can find out first of all is the scale factor, okay? How much bigger does each triangle get, okay? So scale factor. And as discussed already, 9 divided by 7.2. Okay, so 9 divided by 7.2. This part here, this 9 was a length of 7.2. It's now getting bigger. So the green triangles are getting bigger each time. So the scale factor is 9 divided by 7.2, which is basically 1.25. Okay, now we know what 1.25 is. We can now have to figure out what FG corresponds to, right? So FG corresponds to the 8. So what we can say is that the 8 gets 1.25 times bigger. Okay, so the 8 is the one that goes upwards. So 8 gets 1.25 times bigger. And that's going to get me 10 this time around. The 10 is also going to get 1.25 times bigger. And this is going to turn into 12.5. So e.g. FG is going to be 12.5 meters. Okay. Now, find the length of BD correct to 3 decimal places. So let's find out what BD is, okay? So we're just going to rub out some of this stuff here. Now, where is BD located? So BD is located in here. Okay. Now, what we notice is that we have a bit of a sandwich going on here. What we have is we have 2 angles, we have 2 sides, and we have the angle in between. It means we're going to use the cosine rule. Now the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. When you choose the angle you're using, which is going to be the 60 degrees, you have to choose the side that's opposite it. We call it length y. Okay, if we want. So what we're going to have here is we're going to have y squared equals. Now, since we've picked y squared as a, and we're going to pick 60 degrees as cos a, the other two, let b be 8 squared and c be 9 squared. Okay, so equals 8 squared plus 9 squared minus 2 times 8 times 9. That's your 2bc cos 60. You just want to put that directly into the calculator. Okay, and what we're going to get here is 64 plus 81. You can just put it directly into the calculator, to be honest. Minus 72. Y squared will equal 73. And y therefore will equal the square root of 73, which is equal to 8.544 meters. Okay, next part. Part 3, find the length BD, we just did that. The center enlargement is O. Find the distance from O to the point B. Okay, so we need to find the center of the enlargement, okay? So we need to go back to our diagram. So the center of the enlargement. Now, and once we define the O to the point B. Okay, so what we're going to do here, just pause it for a minute. Now what I'm saying is the center enlargement is O. Now what enlargement is basically, if you're to continue this line all the way across, I'll just do it in the form of rays here. Okay, so if you continue this line all the way across, what you do is your line would continue. Okay, and I think we need to just make this this part here just slightly smaller again. Okay, and what we'll have here is we'll have a line. Okay, so if you imagine you continue the line across all the way across. Okay, so it just basically keeps going. That's your line there. And you just imagine the triangles just kept getting smaller and smaller and smaller until they didn't exist. This here is what you'd refer to as your center of enlargement. Now, what's happening here is basically the center of enlargement is O. So let's call this point O here. And what it wants to do is find the distance from O to B. So it wants me to find this distance here. Okay. And so what we can do is we can compare the enlargement from OB to OD. BD here, okay? So we know that BD is, we just after getting this a second ago, is 8.544. Okay? So if you know that the enlargement OD in comparison to OB, okay, that has to be 1.25. Now the reason why it has to be 1.25 is that this length here, I'm going to draw out these two lengths here. The blue length is OD, okay, and the green length was OB. Now because it's 1.5 times larger each time, this means that OD has, since it's 1.25 times larger each time, OD has to be 1.25 times larger than OB. So what we can say is that OD is going to be X plus 8.544 and OB is simply X. Now what we can do now is we can cross multiply and try and solve what X is. So we're going to get 1.25X equals X plus 8.544. We can bring the X over to the other side and we get we're going to get 1.25X minus 1X equals 8.544. Then what we can get here is 0.25X equals 8.544. Divide 8.544 divided by 0.25. And what we can realize then is X is 34.176 meters, okay? So now we know that the distance from the point B to the center of the enlargement was X, and we know that X is 34.176 meters. Extremely difficult question, and not many likely to get it. Okay. A condition for the planning is that the height of the point G above the horizontal line BF cannot exceed 11.6. Does the planning meet this condition justify your calculation? Okay, so what we need to do is go back to the original diagram and we can just rub out our constructions from earlier. Okay, and we'll zone in on what we're looking to do here this time around. Okay. Okay. So what we're looking to do next is we're looking to find the condition is to plan the height G, point G. So where is point G? Point G is located here. This is point G here, and it cannot exceed 11.6 above the horizontal line. Okay, so if we were to drop the line down here, okay, so this is the horizontal line here, continues across, and G goes directly down. That cannot be above 11.6 is basically what I've been told here. So this cannot be bigger than 11.6. So I had to figure out what is this height of this diagram, okay? Now, what we know is that this, let's call this angle alpha. Okay, this is angle alpha. So the angle GFH, and we'll call this point H here. Okay, so call this angle alpha. Okay, and alpha equals CBD. CBD. Okay, so angle alpha is the same as CBD, because look, they're the same angle, so this is angle alpha here. Now, because this is angle alpha, what we can do is we can use the information we got from this triangle previously to find out what angle alpha is, okay? So to find out what angle alpha is, we're going to use the sine rule here, okay? So what we're going to do is we're going to use the sine rule. So sine, sine 60 divided by what's opposite it, the 8.544 we got earlier, equals sine alpha divided by 9. So therefore sine alpha, bring the 9 up here, it's going to be 9 sine 60 divided by 8.544. So 9 sine 60 divided by 8.544, and what we're going to get is, when we just rub this out here, we're going to get sine alpha equals 0.9122. Remember, to separate sine and alpha, you bring sine across and it becomes sine inverse. So sine inverse your answer. So alpha equals sine inverse. Now you got to show all these workings I'm doing at the moment on into your book, right? So sine inverse your answer, and what we get is alpha is going to be 65.82 degrees. Okay, so 65.82 degrees. Okay, so what we can say here is that this here is now 65.82 degrees. Okay, now we're back working on a right angle triangle now. Okay, so we can rub out all our workings from earlier, and what we can now say is that, remember, because they're enlargements, these angles are all alphas, okay, in the same way that all of them are 60s. So this was alpha as well, which was your 65.82, right? So this was another alpha, and that's why we worked it back that way. We worked it back to the triangle with the most information. So this is 65.82. Now, what we know about this one is it's 12.5 meters from earlier. We need to find h. This is a right angle triangle. You're going to bring SOHCAHTOA into play. So SOHCAHTOA. And what we need to use is sine, because this is the opposite side, and this is the hypotenuse. Okay? So what we're going to get is sine 65.82 equals h over 12.5, opposite divided by hypotenuse. Bring 12.5 up, and h is going to equal 12.5 sine 65.82. Put that into your calculator, and that is the end of the question, and we should hopefully see whether the height goes above 11.6. So see now, 12.5 multiplied by sine 65.82, and height is 11.4 meters. Okay, so it's just above, it meets the condition. It's 11.4 meters, which is below what they were looking for. Does it? Yes, it's 11.4 meters. Now remember to all your workings in here, the workings I did on the other page. Okay, so this is where your workings are going. Alright guys, now we have one little part left, which is the trapezoidal rule. Okay, so in order to estimate the area of this irregular shape, horizontal is drawn across the widest part of the shape, and 5 offset perpendicular lines were drawn at equal intervals along this line, as shown. Find the length of the horizontal lines and the offsets taking each grid unit as 5 millimeters. Okay, so here to here and all the way down. This is seven blocks. 7 multiplied by 5 millimeters, 35 millimeters. Okay, the next one is 1, 2, 3, 4. It's 9 by 5 millimeters. It's going to get you 45 millimeters. This from top to bottom. The next one after that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 by 5 millimeters is going to get you 60 millimeters. Okay. After that, we're going to be getting another 40. 1, 2, 3. It's 8 by 5. 8 blocks by 5 is going to get us 40 millimeters. And then finally 1, 2, 3, 4, 5, 6, 7, 8. It's going to be another 40 millimeters here. Okay. The next thing we can say is that we need to find out what the common gap is. The common gap is a good 4. It's each one's worth 4. So what we can say is that this here is 20 millimeters per gap. Okay, so each gap is worth 20 millimeters. You don't really have to go about doing much else than that, okay? And the entire length of the full thing, because it's 1, 2, 3, 6 of them. Okay, so if you were to go from here all the way to here, that'll be 120. Okay, so that'll be 120 millimeters in total length. Okay, now that you've done that, what we need to do is we need to find the trapezoidal rule in your notes. And what the trapezoidal rule is, it's on page 12 of your papers. And the trapezoidal looks something like this. Area. Now see these squiggly lines? It means it's roughly, it's an approximation, it's an estimate. Okay, h over 2 y1 plus yn plus 2 times y2 plus y3 plus y4 plus dot 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 dot. Okay, now what that means is basically y1 is, it'll tell you in the tables, y1 is the first one, the very first length, and we can see that y1 is 0 in this question, and yn is the very last length, and yn is also 0. Okay, this one here is y2, y3, y4, y5, y6. Okay, so now that we've done that, the area is h over 2. Now h, ironically enough, isn't the height. It's actually the distance, and once again it'll tell you in the graph that h is the distance between your intervals, right? So it's 20. H is 20 over 2. y1 is non-existent, so it's going to be 0. yn is going to be 0. And then it's 2 times the remaining y's all added together. So 2 times everything else added together. So we have to see what everything else is. Up top here, it's going to be the 35, the 45, the 60, and the 2 40s, okay? So it's going to be 35 plus 45 plus 60 plus 40 plus 40. Okay, so it's all going to go in here, and that's going to be 10 into 0 plus, and this is going to all turn into this here when you just put it in all into the calculator, okay? So, and don't forget your other closed bracket here, it's going to get you 440. Okay, that's going to be 10 times 440, which is going to be 4,400. Now what are we talking about when we talk about 4,400? We're talking about millimeters squared. Okay, and this is an estimate of the entire thing, okay? Alright guys, that's the end of this paper. Last question was easy enough. Question before was quite difficult, okay?